Hello, so my name is Justin Clifton, and today I'm going to be talking about the research I did over the summer with faculty advisor Dr. Mark Button. So we did our research in a field of mathematics known as Ramsey theory, and Ramsey theory has actually been studied for nearly a century at this point. The general idea behind Ramsey theory is to take some original structure and then to partition it in pieces and see at what size of the original structure can we guarantee that some substructure must exist in one of the partitions. So these numbers are actually notoriously difficult to find. There are actually only two non-trivial multicolor Ramsey numbers for which the exact value is known, and our research focused on finding more of these numbers. So the structure that we studied is called hypergraphs. And a hypergraph can essentially be thought of as a collection of objects or vertices with some relationship with each other. And that relationship is denoted by the shapes, and those are called edges, and the circles or the dots are called vertices, and those are the objects. So one special type of hypergraph is a complete hypergraph. This is actually an example of the original structure that we're going to partition and try and find substructures of. So this is a complete hypergraph, which is a hypergraph where every edge that can exist does exist, of three uniform, which so every edge has three vertices, and it has four vertices total. Another special type of hypergraph is called a hypergraph tree. This is one of the substructures that we're trying to guarantee the existence of. And this is a three uniform tree with seven total vertices. Another substructure that we were trying to guarantee the existence of is called a star. The significance of the star is that there are, in this case, four vertices common to each edge. So this is a five uniform star with four vertices and nine total vertices. So our methodology was done by finding bounds, upper bounds and lower bounds. An upper bound is a number that must be bigger than the Ramsey number, and a lower bound is a number that must be smaller than the Ramsey number. Upper bounds are generally found by showing that a certain subproperty must exist at a certain point, in our case, a subgraph. And a lower bound is done by showing that a certain subproperty or substructure cannot exist at a certain point. So one new bound or one new result exact evaluation that we found is the Ramsey number for two stars, two three uniform stars with two shared vertices and a total vertices of 4 and 6 respectively. And we found that that equaled 7. But this is only one result that we found. We actually found a bunch of new results. And this is a table of some of the results that we discovered. So as you can see, we found quite a few. Our future directions involve showing that all tree hypergraphs have this property of being in good, and we hope to approach that soon, perhaps the further development of this research. And here's some sources that I cited. So thank you for watching. I appreciate it.